Hello learners, I welcome you all to this mathematics class. We have already studied about triangles, particularly right angle triangles in earlier classes. Today, let's take some examples where right angle triangles can be formed. Suppose some of our friends are visiting New Delhi and they are at Qutub Minar. A friend of yours stands at a distance from Qutub Minar and looks the top of the Minar. Can he tell exact height of Qutub Minar without measuring it? Yes, that is possible using some mathematical techniques which comes under a branch of mathematics called trigonometry. You see, suppose this is the tower. You see, suppose AB is a tower at the Minar and your friend stands here. A right angle triangle can be formed by this way. Can your friend tell the exact height of the Minar without measuring it? Yes, it's possible by using mathematical techniques which comes under a branch of mathematics called trigonometry. It is derived from Greek words like trigonometry. Tri means three. Gon means sides. And meter means measurements. So trigonometry comes under a branch of mathematics. It is the study of relationship between the sides and angles of a triangle. Yes, we can say it is the study of relationship of the sides and angles of a triangle. The earliest known work on trigonometry was recorded in Egypt and Babylon. Early astronomers used it to find out the distance of stars and planets from Earth. Today also, it is used in engineering and physical sciences. So today, we will discuss some ratios of sides of a right angle triangle with respect to its acute angles only. We will study the trigonometric ratios for some specific angles and establish some identities. You see, what are the ratios? You see, some ratios are there. First is sine. Next is cosine. Next is tangent. Then fourth is cotangent. Next is secant. Last one is cosecant. So sine, it is described in Aryabhatian by the Indian mathematician Aryabhatta in 500 AD. It is discovered by Aryabhatta as ja, ardha ya. It is described by science as jya or jiva, but later it translated to Arabic and to Latin it came to sinus. Then by some professor of astronomy, Edmund Gunter, shortened it to sine. Similarly, there cosine that came to cos by some English mathematician Sir John Moore. Similarly, tangent came to be known as tan, cotangent came to be known as cot, secant came to be known as sec, and cosecant came to be known as cosec. So these are fixed trigonometric ratios, and just we'll see how they are formed. Let's consider a right angle triangle. Right angle at angle B. Angle A is an acute angle. So we will now derive the trigonometric ratios of angle A. So first of all, we will see sine A. This is very important class. This is basic. This is foundation class. If you learn this class well, then you will do better mathematics in future. We know ratios in your previous classes. Sine of angle A is equal to side opposite to angle A divided by hypotenuse. Similarly, cos of angle A is equal to side adjacent to angle A divided by hypotenuse. Similarly, tan A, tan of angle A is equal to tan A. Tan A is equal to side opposite to angle A divided by side adjacent to angle A. Similarly, we can tell cot A. Cot A is equal to the reciprocal of tan A, that is side adjacent to angle A divided by side opposite to angle A. Now we will see sec A. Sec A is equal to hypotenuse divided by side adjacent to angle A. And cosec A is equal to hypotenuse by side opposite to angle A. These are the 6 different ratios of acute angle A in a right angle angle ABC. Now we can see from this that sin A and cosec A are reciprocal. So we can say sin A is equal to 1 by cosec A. Similarly, cos A is equal to 1 by sec A. Tan A is equal to 1 by cot A. And cot A is equal to 1 by tan A. Sec A is equal to 1 by cos A. And cosec A is equal to 1 by sin A. So from all these we know 3 new formulae, that is sin A into cosec A is equal to 1. Similarly, cos A into sec A is equal to 1. And tan A into cot A is equal to 1. You can say they are formulae. So one thing we have to consider here, that sin A, it doesn't mean sin into A. It is sine of angle A. It is sine ratio of angle A. One thing you have to remember, that the ratio sine doesn't vary when the sides vary. Suppose MN is perpendicular to AB, we can find another MAN right angle triangle. So BA side reduces to AN and CA side reduces to AM. In this case also, in the right angle triangle MAN, the value of sin A can't vary. It will be same. So the value of ratio sine doesn't vary with the sides of the right angle triangle. So here now we learned about what are the different trigonometric ratios of an acute angle, and we derived some formulae. They will help us solving the problems in our future classes. So thank you for watching this video class. Have a good day. Bye bye.